This is Twit.
Bandwidth for Know-How is brought to you by CashFly.
This episode of Know-How is brought to you by Braintree. Mobile app development can be complex, but integrating your payments no longer has to be. With Braintree, your business can accept nearly every type of payment from any device with just one integration. Learn more at braintreepayments.com/knowhow. And by DigitalOcean. Simple and fast cloud hosting built for developers. Deploy an SSD cloud server in 55 seconds. Try it today for free. Visit DigitalOcean.com, and once you sign up, be sure to enter the promo code KNOWHOW in the billing section to get your $10 credit. On today's show,
you'll know how to build an Arduino-powered camera light.
Welcome to Know-How. It's the Twitch show where we build, bend, break, and upgrade. I'm Father Robert Ballecer.
I'm Bryan Burnett.
And for the next 30 to 45 minutes, we're going to be showing you some of the projects that we've been geeking out to, so you can take them home and geek out on your own.
That's right. And we've been kind of on an Arduino streak lately.
Yes, we have. Arduinos are so versatile. They're so fun, and you can really build a lot of things with them, which is why I started thinking about our Mondays. Our Mondays have been dedicated to a Podcasting 101 series. So I thought, why don't we help them out a little bit? We've shown a lot of really nice camera lights that are crazy expensive. Could we build a better one for less?
Well, it's taking two of the things that I love, Arduinos and LEDs. Bright, shiny things, I love those. But also I feel like we're kind of ramping up towards Maker Faire now.
Yes, we are, which is, you know, it's very Arduino intensive. Anytime you can create a tool that makes fast prototyping not something just for geeks with multi-$1,000 workstations, but something that anyone who buys a starter kit with a couple of jumper cables can create things with, I'm all for it, and that's why we're doing this project. Well, now, let me mention that we actually are putting the robotic Arduino, the Stepduino, on pause because some people wanted to see the lighting thing before we got to Maker Faire, but also because I need to wait for parts.
So yeah, it's a twofold problem. Yeah, most of the time when people ask me, like, what project can I do with an Arduino, like, I always suggest LEDs.
LEDs, and there's something about making things happen in the physical world.
Yes, it's something very visceral. When you see the lights come on, you're like, okay, sweet. Because sometimes you'll write code or you'll program something, and you don't see anything physical happen, but well, the stepper motor was a good example, but also the LEDs will be fun too.
Exactly, and that's what we're going to do. We're going to combine that with our joy of being able to see things. Okay. Now, let's take a look at some of the raw ingredients. We are going to be using these. Now, WS2812, we've been playing with these a lot. This is one of those pixel sticks, so it has 8 LEDs on it, and you can address it via a single digital cable while providing power on these. I've actually soldered these leads to make it easier for us to fast prototype.
How come you didn't do it on camera?
Well,
you didn't want to solder in front of everyone else?
No. Smitty's mad enough as it is. But I will mention that you can use any WS2812 or 2811 lights that you want. So go ahead and choose your favorite. I have a lot of pixel sticks, so I'm probably going to use this, or I'm going to use a high-density SMT strip. The one thing I'm worried about is heat, because in our application, these are going to start to pump out quite a bit of excess waste heat.
Ooh, that's right.
Yeah.
What was it? The giant flashlight that guy made out of LEDs?
You need a big heat sink, because what will happen is the LED will just keep building up heat until it eats itself.
I've got a big heat sink and I need a big LED.
Exactly. If you go to the overhead, Alex, so here's very bare bones. You can make this project for under $10. You need some sort of pixel stick. I got these for 99 cents each. Eventually, I'm going to need a roll of SMDs, but I'm not going to worry about that until we get into the actual building phase. This is still the prototype phase. You're going to need an Arduino. I suggest you get a couple of breadboards. And again, these were like 69 cents each. This Arduino was $2. And then you're going to need some jumpers, enough jumpers to wire up the way that we're going to show you. You need to wire up your Arduino. Looking to the future, you're going to want to get a UBEC, a UBEC. Remember, these are the devices that can take between 5 and 30 volts and turn it into 5 or 6 volts.
Also not very expensive.
$2. But we're going to need this because eventually we're going to want to make our camera light portable. We don't want it to be tethered to the computer.
This is in a studio light.
This is not a studio light, right?
We're going to have this on the top of the camera.
Precisely.
Cool.
Now, people will probably ask, well, that's kind of silly. Why would we spend all this time making a camera light? We've done more advanced projects. I mean, the Christmas light projects were more advanced.
It's pretty advanced, yeah.
However, we talked about something on last Monday's program. We talked about color temperature.
Right, and setting the white balance on the camera.
Setting the white balance on the camera, and then there's ways to mess around with color and brightness so that I can get the right effect. I can make someone look pale and gaunt. I can make them look a little earthy. I can make them look bright orange. I can do that with the white balance on the camera, but I thought, what if I had the ability to do that effect just with the light itself?
Instead of having to slide like a filter in front of it, you know.
And I can do that because, remember, each of these LEDs is actually 3 LEDs. If you go to the side view here, Alex, remember, there's a red, a blue, and a green LED inside of each one of these. And there's a small integrated circuit that allows me to send commands to light up each of those colors to a certain degree. So I can have it all red, all blue, all green. That gives me pure white. Or I can, dial it back a little bit and give myself some bluish light or some reddish light or some greenish light or any hue in between. In fact, I think if you do the math, it's something like 16.7 million possible colors.
That's a lot of colors.
That's a lot of colors. But I need a way to control those lights. And remember, this is going to be a top-of-camera device. So it's not like I'm going to have a laptop connected so where I can assign myself the colors.
Have a USB plugged in to a laptop connected to your camera that you then have to plug it in? No, that wouldn't work.
There wouldn't be much call for that. If when the laptop you need to carry is larger than the camera light, that's a bad thing.
And then I'm guessing you'll have to have a separate power source because you don't want to be tethered to the wall while you're walking around with this Arduino.
So those are all the things we need to consider going into the prototype phase, because this prototype, once we get it the way we want it, that's the machine that we're going to build into our actual enclosure. And of course, there's going to be some 3D printing involved here.
Oh, well, yeah, I mean,
naturally.
We love our 3D printer. It's perfect for that stuff.
So here's what I suggest. What I suggest is that we build a prototype that has 4 inputs. That's 3. 4 inputs.
There are 4 lights.
4 lights!
4 lights.
If you don't know where that's from, go Google it, watch it. It's a great clip. But what we want is 1 knob each, 1 potentiometer each to control red, blue, and green. So we can dial it all the way down or all the way up.
And do your own custom mix effects.
Exactly. Perfect. And then we want 1 more for brightness. So once I get the color I want, I can dial the brightness up and down without changing the color saturation ratio.
May I make 1 more suggestion?
Sure.
Maybe 5 switches and have one for rave. Just turn it all the way to the right and it just starts blinking different colors and stuff.
So it's sort of like red, blue, green, brightness, and just get it done.
Yeah, exactly.
All right, I'll consider putting that into the finished product. All right, let's take a look at what this is actually going to look like. I have a very crudely drawn...
Actually, to be fair, Padre, you've gotten a lot better.
This is much better than I normally do.
I can actually legibly read that.
Okay, so we've got a really bad simulacrum of an Arduino.
That's what that is.
I just put these are the digital pins, those are the analog pins, plus we have my 5 volt, and my 2 ground.
See, I thought it was somebody's mouth with teeth.
You're not helping.
Okay, go ahead.
We're doing some serious science here. All right, so I've got my Arduino, and remember, I am using an Uno, so I'm going to be using my standard big one on a breadboard 3D print that I made. But you could do this project with a Nano, with a Pro, anything that has an Atmel. I think you need a 328 or better. That's going to have more than enough memory and oomph for you to be able to power it.
Okay.
Now, I have my 4 pots, and I have my WS2812. And the nice thing about WS2812 is it doesn't matter if it's 1 light or 100 lights, you're still going to have power and then the digital line. So I've got my 5 volt, I've got my ground, and then I've got my digital line in between. Remember, the way that potentiometers work, let me bust one out here. So I bought a bunch of these. If you go to the side view here, Alex, this is a potentiometer. I've got 3 leads. One of them has to be ground, one of them has to be voltage. This is the wiper lead, the one in the middle. So that's the one that will change when I turn the potentiometer. That will change the amount of voltage that's actually going through that wiper lead.
Right,
Okay?
right.
So what I need to do over here is I need to provide 5 volt on one side, I need to provide ground on the other side, and then I need to get this over to one of the analog pins.
Right, because that's the digital connection.
Well, that's the analog connection.
Or the analog,
Right,
yeah.
right. So these analog pins will read the amount of voltage that's coming in from the potentiometer, and it will turn it into a value.
Right, and we'll have to set the parameters in the code and stuff.
Yeah. We're going to have to tell it what numbers belong to what. Well, we'll get to that when we get to the programming. But let's do this really quickly. So what I want, this is actually kind of weird. I'm going to go ahead and connect all the negative pins. And then I'm going to connect all the positive pins.
And then just do one wire back to the Arduino?
Right, exactly. So now but make sure you get this straight, because you don't want to connect negative to positive. You'll blow it up. So do it the same. Positive all on one side. So in this case, positive's always on the right.
Right.
And the negative or ground is going to be on the left. And then I just connect this to my 5 volt, and I connect this to my ground. Okay, so that gives power to the potentiometers. Now I need a way to get back from each of those wiper leads to analog 0, 1, 2, and 3.
Right, you wouldn't want to put one wire for all of those.
Right.
No.
Well, I mean,
that would defeat the purpose.
It would look like garbage. The voltage would keep fluctuating. Now, I would normally use a different color piece of chalk, but unfortunately we don't have another color piece of chalk. So this really simply goes analog 0, analog 1, analog 2, and analog 3. Does that look confusing enough yet?
It's beautiful.
It's beautiful. Just imagine that was in a different color.
Okay.
All right. So that gives me all of my input. Those 4 potentiometers are now connected properly to my Arduino. So when I turn them, I can get different values inside the Arduino.
Perfect. Yeah, that makes sense.
Okay. I also need to provide power to my WS2812. So I'm going to take this from the 5 volt, and I'm going to bring the ground down to there.
Well, you've already messed with my head, because you said the ground was always on the left.
Well, yeah.
And the power is always on the right.
Whatever. That's cool. As long as you put the ground into the ground and the power into power, we're happy.
Yeah.
Now, this is going to change, because I'm drawing, for the purpose of the prototype, I'm drawing all power off of my Arduino. I will not be able to do that once I get like 160 LEDs in an enclosure. That's just
right, because it'd be pulling too much voltage.
Way too much voltage, which is why I'm going to need the UBEC. I'm going to need to be able to provide voltage to the Arduino and to the LEDs separately.
How many WS2812s do you think you would use?
I'm probably going to put at least 80. So like
80?
10 of those pixel sticks.
And just stacked on each other?
Yeah, just stacked right on top of it. Because I mean, they are surprisingly bright when you ramp them up to full brightness. We've never, ever on this show used full brightness because it's just too bright. It blows out the cameras. But we're going to do it for this project.
Cool.
And then I need to get one digital pin. And actually, I'm going to pull the digital pin from over here. And for this project, I'm going to put it into digital 3. But I can put it anywhere as long as I remember what digital pin it's attached to.
Okay.
So in a super confusing, please don't use this picture because I didn't have the right color chalk. This is what we're going to be doing today with our prototype.
Okay. I think we've got the right idea.
All right. So let's go ahead and start. The first thing I'm going to notice, if you go to the overhead, Alex, is I actually only have 2 of these potentiometers.
Right.
That's how I designed this board. So this is sort of a modular breadboard. So I'm going to go ahead and add myself a secondary breadboard here.
Nice.
And then I need to add 2 more potentiometers. Again, if you go to the link there, Alex, I put a link for my, these are cheap. I mean, these are less than $1 each. I have like 100 of these things at home because I always use them. They're very, very useful, very inexpensive, but they also break when I use them the way I use them.
How would you break them?
I'm like an abusive inventor. All right, so what I'm going to do is I'm going to go ahead and just put these into the board, like so.
And then bend it down?
Bend it down. See, look at that. It's so beautiful, Brian. Boom. Okay, so now I've got my 4 potentiometers. It really doesn't matter which one is which. All I know is that one is going to be red, one's going to be blue, one's green, and then one is brightness.
Right.
Any of them can be any of those.
Right.
Now, just like in the drawing, I need to provide power to this, and then I need to draw digital connectivity back. So what I'm going to do is I'm going to say the
left is negative.
well, I'm going to
ground.
right is going to be my positive, and the left is going to be my ground.
Oh God, wait, your left or my left?
Mine. It's always me. So what I'm going to do is let's go ahead and daisy chain this. See, super simple.
So this is the power.
This is the power, because I need to give power to all of these in order for them to give me a value back. Do that.
Right.
Go.
And for anyone who's wondering how a breadboard works, all of those little columns connect or the same line.
Right. So if you're in that same vertical line, it's the same thing. You're touching the same conductor. Okay. So what I've done is all of those positive pins are now linked to one another.
Yep.
So all I have to do is provide power to this one, and it provides power to them all.
Boom.
Okay. And let's do the same thing for the negative. So negative's on this side, on my ground. And there we go. Ground, 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 and one more ground, and ground. Okay.
Yeah, definitely use breadboards before soldering.
Exactly. And again, double check your work. Unfortunately, I don't have a lot of the same colored leads anymore. They've all disappeared, which is strange. Go back to that shot, Alex.
Burke.
Make sure that all of your power colors are in one slot and all of your ground colors are in another slot. If I accidentally did this, then when I apply power, it would actually just blow it out.
Oh yeah.
Which would that would be a bad. Let's not do that.
That's a no-no.
That's a no-no. Let's not do that. Then I also need to provide power from the Arduino into my potentiometer. So I need one more set. Here we go. Let's take this one and this one. So we're going to go from power ground. So that's the ground pin right there. Here. Then I'm going to go from 5 volt, which is right there, and it's going to go right there. Okay, so these are now receiving, or when I powered up, these will now be receiving power from the Arduino. I need to get that data back.
Right. So that's what the middle one
Precisely. So I'm going to use green and yellow on this one. So let's go ahead and do green first. So I'm going to take this, and remember the way it works. So this is on the same line as the wiper. And that's going to go into analog 0. This one is going to go into, let's see, right there, analog 1. This one is going to go into analog 2. And the last one goes into analog 3. Now, you will be very happy to note here, Brian, that there's 2 more analog pins that I could use. So if I wanted to add your rave function, I can totally do that.
It's available.
It is available.
Good.
It is available. All right. So this has me wired up for the potentiometers. I need to get my WS2812 wired up as well.
Right. So you'll have the ground, the power, and then the digital pin.
Correct. Exactly. So ground on this one is gray. So I'm gonna pull from the second ground port and pull the power from the second 5 volt power port. And in my programming, I set it for digital pin 3, which is going to be right there.
Right. And you could set that to whatever you want.
Right.
Really.
So 0, 1, 2, and 3. Ta-da. So believe it or not, this is the device. That's exactly how the device is going to look.
Well, let's power it on and make sure it works first.
Do we have to? It looks so peaceful when it's like this. It's so, look at it. It's nothing.
Yeah, before
Wait a
it
minute,
bursts
hold on.
into flames.
This was supposed to go someplace.
Why do you have an extra wire?
Why do I have an extra wire?
You got all of them.
Okay, I think I'm
I
good.
think you just had an extra wire.
I think. Oh, and this one's actually in the wrong slot. See, this is why you always double check, people.
No, plug it in now. You had one chance.
You had one chance. And actually, see, these are in the wrong slot. There we go.
They are very tiny slots.
They are tiny.
Definitely
tiny.
double check your work.
There we go. Let me just double check all that. Everything looks right. Good. Okay, so let's go ahead and power it up. Ta-da!
Our mystery pin. Okay.
And I can't remember what code I had on this. Okay, so I did load up the code. So, look at this. So that was my brightness pin.
Yep.
This was, I think that's blue. This one is
green.
That's green, and this was red. Okay,
red,
there we
yeah.
go. Okay, so here, yeah, take the lights all the way down, and let's bring this up. Oh no, take the lights all the way down.
Let's rave.
So we have
Your
red.
hand's covering it. There you go.
Then I can turn down the red, and I'll bring up green. I can turn down the green, and I can bring up blue. And then I can make a combination of any of them just by mixing these. There we go.
If you mix them all at the same value, that'll be white.
Exactly.
Right?
And then this one controls brightness.
It does get really bright.
Yeah, seriously, this gets crazy, crazy bright.
Awesome.
There we go. Go bring the lights back up. So we know that my wiring is right, but we haven't shown them the programming yet. So we're going to be showing them the programming in just a bit.
It's just copy paste, right?
Oh yeah, no. This one's a little bit custom. Okay,
okay.
so but we know that the concept works at least with one strip. Now, when I move this to 10 strips, I'm not going to be wanting to run that off my Arduino. No. And I need to figure out a way to deliver clean power to both my WS2812 lights and the Arduino. Exactly.
Yeah.
And I don't want to use two batteries. I don't want to have two batteries in here. So I need to figure out a way to do that that's not going to like surge the Arduino. Because what I don't want is I don't want so many WS2812 lights, and then every time they refresh, because they add a little bit of noise into the electrical system, I don't want it rebooting the Arduino.
Makes sense.
Yeah, okay. Now we're going to show you exactly how we do that when we get back. But first, we want to stop and thank the first sponsor of Know How. Hey, Brian.
Yes.
You know what I like?
What?
I like things that are easy.
Yeah, me too. Me too.
Like payments. Payments are super easy. I mean, all you have to do is you have to make sure you get a payments processor. You make an arrangement so that you work with a financial company in order to be able to process, say, credit cards or foreign transactions. You also need to make sure you have a secure server and maybe a colo to put the secure server in. Don't forget you also want to have someone who's going to maintain all those systems for you. I mean, easy.
That doesn't sound easy.
No, it doesn't. Actually, it's not easy at all, which is why we're happy to have Braintree as a sponsor of Know How. You see, Braintree is the easiest way ever to start accepting payments on your server, your service, or your app. Braintree understands what developers need. They provide you all the tools, the SDK, and yes, even the help, the backstage help that will make sure that you do the integration right. By next year, maybe even next week, there could be a whole new way to pay. You don't want to have to figure out a new way every time there's a new credit card, a new way to use Bitcoin, a new way to use any e-currency. Maybe it is going to be that next Bitcoin, or maybe Dogecoin is going to come back. But no matter what that next payment's going to be, Braintree has got it for you. Their full-stack payment platform is easily adaptable to whatever the future holds, so that you can adapt along with the currency. Now, you can accept everything from pounds to PayPal to that next big innovation from any device with just one integration. And when that new payment method comes out, all you'll have to do is update a few lines of code. No late nights, no complicated recoding, no stress about staying ahead of the curve. Braintree Payments is here to help. They offer you simple, secure payments, code that you can integrate quickly in just a few minutes. That code supports Android, iOS, and JavaScript clients, so it's going to go pretty much everywhere you want it to go. They've got their SDK in 7 different languages: .NET, Node.js, Java, Perl, PHP, Python, and Ruby. And they've got elegant code with clear documentation, and they include a sandbox, so you can actually test your integration before you go live. In other words, Braintree knows the concerns, the questions, the issues that might arise during your payment integration, and they'll solve it for you. Now, Braintree gives you an easy way to accept multiple payment types with one integration. Integrating it into your app is as easy as inserting a few lines of code. Folks, why aren't you using Braintree? If you're not, you're just working too hard. Learn more at braintreepayments.com/knowhow. That's braintreepayments.com/knowhow. Braintree Payments, the future of payments. And we thank Braintree for their support of Know How. You know, I know we promised them that we were going to show them how we did all this this technical wizardry, all the programming, but you know what?
But we were joking.
We were joking, because I want to make them wait just a little bit more. Instead...
It's called a tease.
Yeah, it was a tease. I know, sorry, folks. But I want to show them something that we came across last year at Maker Faire that might actually be really useful in a project like this. Imagine if you could get the kind of functionality that we're building out of these potentiometers, or from our Arduino project by connecting it to a laptop, but entirely wirelessly through your phone.
I want to play with that.
Well, I want to play with it too, because it's not magic, it's OneShield.
Oh! Oh, no.
It's funny how we can feel far away when we live together on the weekend. Thought still to quit being
Once you've got your Arduino project together, there's one thing that most makers are going to run into, and that is, well, how do you connect it to the internet? If you want to be a part of the Internet of Things, you've got to be connected, which is why we're here at OneShield, and I'm speaking with Amr, who has, well, a unique technology that allows you to use your phone to put your Arduino on the net. Amr, what is this?
Well, OneShield basically allows you to communicate between the Arduino and a smartphone in a really easy way. So whenever you want to buy hardware shields, you don't have to because you already have all the hardware in your phone, right? So your phone can connect to the internet. It has a lot of sensors, a lot of capabilities, and we made that happen with the Arduino. So we designed an app and a board. The app opens the sensors and capabilities, and the board has a Bluetooth module that communicates back and forth between the smartphone and the Arduino board.
If I have a smartphone, I have an amazing cornucopia of sensors, everything from accelerometers and gyros to just a really nice communication platform. You've given me access to that through Bluetooth. Yeah. Now, right now you work on Android. I know you're working on iOS, but how does this actually work? How would I connect to my Arduino device?
Okay, perfect. So it's really simple and easy. So first, you get the board itself, you hook it up on top of the Arduino, and then you have an app on the Android phone. This app opens the phone sensors and capabilities. So you have the accelerometer sensor, it guesses the X, Y, and Z coordinates, right? Or you can make phone calls from the Arduino itself, so it goes both ways. So you control the Arduino itself from the phone, or you control the phone from the Arduino itself, right?
I love the fact that this looks complicated, but it's actually really simple. You've got 4 servos that are driven straight off of an Arduino board, and then you've got the OneShield in there so that you can actually control the motion of what it's doing.
Exactly. So it's really simple. It's really one line of code. What you get is the data of the accelerometer sensor, and then you do a mapping function between the servo motor and the accelerometer data. So whenever you move your phone left, it moves left, and this right, and so on. And you know what's good at the smartphone is a lot of sensors. So you know what that is? A proximity sensor, so you can use it also to grab things up, right? Yeah.
If they want to find out more about OneShield, maybe get one for their making kit, where can they go?
Well, our website is oneshield.com with the double E, oneshield.com. You can know more about the shields. We have over 40 of them, NFC, color sensor, all in only one device, which is the OneShield.
Thank you very much for speaking with us. Thank you very much for sharing your vision for a smarter Arduino. That's Atmel and OneShield. The Internet of Things just got smarter.
Thank you.
I love the shield concept, and believe it or not, we haven't actually used any shields on the show except for when Smitty was on.
Yeah, no, and when we were at Maker Faire shooting that, at first I thought there was something wrong with the arm, because I was like, is he going to connect to it with his phone? Because I thought he was going to draw on it, and it was the actual movement
he was
of
using
the phone.
the accelerometers inside the phone to control what the robot arm did.
Yeah.
And it's things like that I like at Maker. Not necessarily the big exhibits and all the artsy stuff, but every once in a while you get to see someone who used a bit of technology that you've used in the past, but they used it in a slightly different way, and you're like, oh, yeah, okay, that's cool, I like that.
Yeah, now let's hook it up to giant robot arms, so then whenever you could like pick up boxes and stuff.
Naturally, it's SpaceBot.
Yeah.
Who doesn't want SpaceBot?
Whenever you create something like this, you want to just make a giant robot that utilizes it.
You know what, if we didn't, I would weep for humanity.
Right?
Yeah. Now, we will be showing you some of the code, but first let's go ahead and thank the second sponsor of this episode of Know How. Now, Brian, when you've got an app, when you've got a service, when you've got the next killer portfolio, the next killer website, the last thing you want to do is get slowed down by the deployment of that site.
Right. Or I want to also, if it's doing well, scale it immediately.
Precisely. That whole growing pains step that most companies go through, that's very undesirable. When you realize, oh, there's actually demand for my service, but I can't meet it until I pay up $10,000 in order to get more servers, more bandwidth, more X, Y, and Z, and that's going to take time. And in that time, you lose interest in whatever it is that you created.
So you're saying skip the growing pains.
Skip the growing pains and move straight to boom. And that's exactly what DigitalOcean does for you. Now, DigitalOcean is a different way to think of the deployment of your server or your app. You don't have to build out an infrastructure. In fact, you just have to build out that idea. Once you have that idea, that service, that app, that website, you encapsulate it in what DigitalOcean calls a droplet. It's actually a container, a way to get that perfect server, that perfect image, and then run it on DigitalOcean's infrastructure. That's exactly what they let you do. Now, DigitalOcean is used by over 600,000 developers, including Twit's Randall Schwartz, Aram Newcomb, and myself. They let you deploy and configure your droplets via a streamlined control panel or a simple API, and you can choose your OS, Ubuntu, CentOS, Debian, Fedora, CoreOS, and FreeBSD. You can select from one of the many pre-configured one-click installs. They've got Drupal, Docker, Node.js that let you get up and running immediately, or because they give you root access, you can build exactly the infrastructure that you want. It's highly scalable to meet the demands of a rapidly growing application or business. That means that you could start with just one CPU, maybe a one SSD, and a little bit of bandwidth so you can test the deployment. And once you know that it's ready to go, once you know it's ready for public consumption, once you realize that people actually want to use your service, with the click of a slider, you could deploy it around the world on thousands, hundreds of thousands of CPUs and terabytes of SSD array space. They've got an extremely active community, which I like because it means that the company stands behind its customers and the customers stand behind the company. It's the perfect synergistic circle that lets newbies know that this company is going to take care of them. And you can also use advanced features like floating IPs for high availability, private networking, and automated deployments via API. It's so easy to get started. You can deploy an SSD cloud server in as little as 55 seconds. Here's what we would like you to do. We would like you to try DigitalOcean. They have incredibly affordable and straightforward pricing with servers starting at just $5 a month. And there's also hourly pricing available if you just need to test, starting at less than a penny per hour. But we're going to make it so that you can get started today and deploy an SSD cloud server for free. Just visit DigitalOcean.com and create an account. Once you confirm your email and account information, go to the billing section and enter the promo code KNOWHOW for a free $10 credit. That's plenty to get started and explore what DigitalOcean can do for you. Again, that's DigitalOcean.com, DigitalOcean.com. And once you sign up, enter the code KNOWHOW in the billing section to get your free $10 credit. And we thank DigitalOcean for their support of KnowHow. All right, Brian, I think the tease is over.
That's right.
Let's give them the code.
Let's get into the code.
X going to give it to you. All right.
It's a very exciting intro to programming.
Hey, programming is sexy-ish.
Said no one ever.
No. All right, Alex, if you go ahead and show my screen, this is our standard IDE sketch screen, and it's going to include a lot of the things that you've seen from our previous WS2812 project. So, of course, I'm including the fast LED library.
Well, of course, yes.
That gives me the ability. I mean, I could access WS2812 lights by writing all the code, but why?
Right.
Someone already wrote a library. It makes it very easy for me to address these lights. I'm defining my data pin right here, so that's why I have it hooked up to 3. If I wanted to hook it up to a different pin, I would just change it here. Pin 0, pin 7, pin 11, whatever I want. Here, I'm going ahead and I'm telling it what type of LEDs I'm connected to. And in this case, I'm connected to WS2812 lights, but you might also have WS2811. This is where you would change it.
Right.
The next part is define the color order, and I'm going to go green, red, and blue. And then this is actually an important one, the number of LEDs.
Right.
I've only got 8 on this stick, so I'm saying 8. But if I was going to go ahead and do the full project, I would say 80 or 160, whatever it's going to be.
8,000.
Precisely. And remember, WS2812 lights are daisy chained, so they just go from one digital pin out to the next digital pin in. And I could keep, actually, I think right now the maximum number of WS2812 lights I've connected in a string was 1,500.
It's pretty
I think
good.
about 1,500, yeah, and it was fine. It was great. This one is frames per second. This is not so important for this project, but it's part of the library, so we've included it. When we were doing animation and when we were doing weird things, this is kind of how fast would it refresh the frames.
Right.
I'm not doing any of that. I'm doing a solid color through all of my LEDs. I'm just telling it this much red, this much blue, this much green, this much brightness. So I actually could set this to 1 frame per second, but I'm going to keep it at
wouldn't
120.
really make a difference.
Yeah, it's not going to make a difference.
Okay.
All right, so this line, let's do a quick refresher course for those who have forgotten what we did with WS2812 LEDs in the past. This is going to create an array. This CRGB that's created by the fast LED library. It's an array called LEDs, LEDs actually, and then I'm going to set that for the number of LEDs, which I defined up here. So all that means is that whatever number I put there, this is now going to create an array that size.
Right. And if you had not enough of a number, so say you had 7, then the last one wouldn't, because it just passes the data down the line.
Right, exactly.
Yeah.
So really quickly again, here's how WS2812 LEDs work. Every LED gets 4 bytes. You've got 1 byte for red, 1 byte for blue, 1 byte for green. And 1 byte means 256 possible combinations, which means the numbers 0 through 255. Because 0 to 255 is actually 256, right? So I've got one of those for red, blue, and green, and I've got one more for brightness.
Right.
So those are the 4 bytes that every LED is going to receive. The way that I light up a strip of WS2812 LEDs is I create an array, let's say there's 10 LEDs, of 40 bytes. Now I'm going to push that array of 40 bytes down the string. Every LED is going to take 4 of those bytes, and it's going to pass it on.
Right.
So if I don't assign enough, it means at one point it's just going to run out of bytes, and
nothing will happen, right?
Nothing will happen. All the LEDs down the line will just go, I guess I'm not doing anything.
Okay.
All right, so next part, I'm creating a holding spot for brightness. You'll see why this is going to be important later on. We need to have a variable that's going to want to hold the value for how bright it is. We already have values for the colors because that's created by this array here.
Right.
Okay. All right. Now setup. Remember the setup in an Arduino sketch just prepares the board for what's about to come. There's no real hardcore programming that's going on inside this. In this case, I'm setting up a 3,000 millisecond, so 3-second delay, which allows the device to start up and get ready. I'm opening up a serial port, and again, the only reason why I'm opening up a serial port is because at some point I'm going to want to send debugging information back to myself.
Right.
This is mostly when I'm just starting out and I don't know why things aren't working. I can use this to sort of, oh, okay, this is the value it's getting. I need to figure out why that's happening.
Right. We've used that for setting the threshold, right?
And that's what we're going to do again here. Then this is part of the fast LED library. You can basically just copy this verbatim. This is a line that you get from the fast LED library that tells the sketch, go ahead and open up this library. You're going to use this type of LED. This is your data pin. This is your color. These are all the starting parameters so the Arduino knows how to access the lights.
Okay.
And this last bit, this is just, I set the initial brightness for my LEDs, which I'm going to change later on.
Okay.
All right. Now let's go to the loop, because the loop looks a little bit, well...
there's a lot of integers there, some if statements.
Yep. So here's what I'm doing. I need to do a read 4 times, one for each one of my potentiometers. We're going to start with red. So I've assigned red to the potentiometer that's attached to analog pin 0. See how the 0 is?
Because we did 0, 1, 2, 3.
0, 1, 2, 3. So what this is going to do is it's going to create a variable, an integer, called red potentiometer.
Makes sense.
Okay? Then I'm going to fill that variable with the value from this, analog read 0. So it's going to say, hey, look at analog pin 0.
And where is it set?
Find that setting, and then put that value into the integer I just created called red pot.
Cool.
All right. The next one, the problem with that is a very wild number. It could be between 0 and 1024. Some of these values, I mean, they're not perfect because, again, they're analog. I need to turn that into a number that's actually usable.
Right.
And for me, because I've got a byte available for red, I only have 256 values, which means anything that's out of the limit of 0 to 255, I cannot use. In fact, I'll show you in just a bit what happens. If you try to put this number directly into the array, what will happen is every time you get to a multiple of 256, it goes full brightness and then back dim, and then all the way to full brightness, and then back dim, and it's not good.
Okay, and that's why we have to set up the brackets, right?
Correct.
We like cut up the different portions of from 0 to 256.
Right. Well, we're going to do what's called a map. This was a function that we've used in the past. This is this next line here. So I go int red value. So not red pot, but red value. In other words, the red pot contains the raw value I'm getting back from that potentiometer. Now I'm going to turn it into something else. I need to turn it into a value between 0 and 255. That's the only thing that this LED array is going to understand. So I'm using a built-in function called map. The map function is incredibly useful, and a lot of people don't use it. I'm really sure why. So I create an integer called red value, and I'm going to fill it with a map of red pot. So I'm going to take the value from the variable red pot, and then these two numbers say between this and this, turn it into
0 to 255.
And that, precisely. So this does all the math for me. So rather than me trying to figure out where each of those sectors ends and begins, I'm letting the Arduino do it.
Right.
I'm saying, okay, the only values I care about are when this potentiometer are between 70 and 850. And I set those because those are values that kind of don't drift that much. Okay? And I'm saying when it's 70, it's 0. When it's 850,
full.
It's 255.
Right.
Okay?
Makes sense.
Makes sense, and that gives me my values. Unfortunately, there's an exception here.
Why?
Okay, so when I use this mapping function, and I set it for 70, if it's less than 70, it will actually go into negative numbers.
Doesn't that just mean it turns off?
Unfortunately, no, because the array will just freak out. So, negative numbers? I didn't have any negative numbers here.
Okay.
And then when it goes over 850, I'll actually start getting numbers above 255, which again gives me that problem of once it hits 255, it turns off and then starts brightening again.
Okay. Is that why you have the if statements?
I do. Have you ever heard of error correcting?
Yeah.
Error checking. That's exactly what we're doing. We need to put something here that's going to say, don't let this value fall below 0 or go above 255.
Right.
So what I've done is I've got another set of statements here. This is if the red value is greater than 255, set it to 255.
Yeah.
So it doesn't matter what number it might be. It might end up being 500. It will set it to 255.
Right.
And then this one is the other side. If the red value drops below 0, set it to 0. So this is actually something that you should really be doing in a lot of your programming. This is a condition check. This is an error check.
Right.
This will not allow the remap function to provide me a value that will crash my WS2812 lights.
Right, and this is actually, when I was taking the C++ class, they were teaching that you have to do the error checking because when somebody can then destroy your program by putting in a value that you didn't think, like why would somebody put a letter character in a field that's supposed to be only numbers?
Precisely, and actually this could go back to our Stepduino. We are going to set it so that like hitting A makes it rotate this way and hitting D makes it rotate that way.
Right.
But what are we going to do when people start just pounding on the keyboard and adding a bunch of weird characters?
Right.
We need to check for that because there might be a condition where like they enter a special character and suddenly it exits out of the sketch. So I need to put something there that's going to say only if it's these values do anything. Otherwise, just disregard it. That's essentially what we've done here.
Yeah, I mean, isn't that kind of the what hacking, or like you look through people's code and see what you can do to break it?
Precisely, and 90% of the time it's because someone did not think about someone doing something deliberately wrong.
Right. No, that's fascinating. I like that.
Okay.
Cool.
Now, all of the other code in this loop, it's the same. I do it 4 times. So this one does it for the red pot, this one does it for the green pot, this one does it for the blue pot, and then I have one more for the brightness. Cool. But they all do the same error checking, they all do the remapping, which is take a value, map it between 0 and 255, then make sure it's only between 0 and 255.
Right.
All right. Now, because we learned we don't want to put everything in our main loop, I went ahead and subdivided the functions here. This first function that it calls, because anytime you see the name of a function and then these brackets, it means I'm calling it. I'm calling a function called write debug, and then I am passing it these variables. I'm passing it red pot, red value, green value, blue pot, and blue value. And what will happen is it will call this function, debug, which receives those 6 variables.
And then it'll print out the numbers for you?
Precisely. And that's my debug screen.
That's cool.
Okay, so I don't have to do that. I could take that function out.
Yeah, but this way at least you can monitor it.
Precisely, if something goes wrong. Then I call a second function, light up array. And can you guess what that function does?
It lights up array?
It lights up the array. And I'm going to pass it the red value, the green value, the blue value, and then the bright value.
Right.
And can you guess what those do?
Yeah, I think they make sense.
Exactly. So this is what that function does. This is actually super, super simple. That function is going to receive all the values I just passed. Then it's going to run a for loop. And that for loop says for 0, so the starting cell of the array, all the way up to the number of LEDs, so the maximum number of LEDs that there are in the array.
Which we set to 8.
Precisely. Set, this is important, set RGB, red value, green value, blue value. So it's going to go through the first cell, and it's going to give it the values that I just created with my potentiometers for red, blue, green, and brightness. And then it's going to go to the next cell and do the same thing, and the next cell and do the same thing. Essentially, what I'm doing is I'm building up that array.
Right.
Right. So for this 8 LED strip, there's going to be 32 values.
And it does all this like instantly, right?
Right. This is going to happen really, really quickly. And then this is going to go ahead and push it. It's going to push it down the line and say, go ahead and display all that data that I just gave you. Go ahead and push it down the line and let the array take it.
Okay.
Okay. Then this last one, this allows me to set the brightness according to the bright value. So separate from the colors, I have something that can control the brightness.
Okay.
Now let's go ahead and kick this off so you can actually see what we've done here.
Yeah.
Yeah,
I want to see the data coming in.
So serial monitor. Come on, there we go. So I'm starting to see these are the values of my red, my blue, and my green. So let me go ahead and turn this one all the way down. Notice how that first one goes to 0, right?
And that's red, right?
So the first value is the actual value of the potentiometer. That second value is the remapped value.
Right, the one that's set between 0 and 255.
Right. And you'll notice that it's always going to stay at 0. It's not going to go, and it will never go negative. And also, if I turn this all the way up,
do max. Yeah, what's the maximum on the?
It will max out at 255.
Okay.
And that's my error checking statement because right now
it's at 800, almost 900.
Yeah, if I didn't do that error checking, right now that 255 would be like 260, 270, 250, 240.
It'd be freaking out.
It'd be freaking out, and then this light would be freaking out.
Yeah.
Okay, so let's go ahead and look at the second one. So let's turn this one back down, and this is the same thing. So I've set my low value. In fact, actually, let's go full screen on that. Here's an interesting thing. Because potentiometers are analog, I have an interesting thing going on here. That number won't go below 7.
Right.
7.6.
And that's just inherent?
That's totally off. That's completely off, which is why I need to calibrate it. And the way I calibrate is up here, because remember, I set my map values, 70 to 850. If I was having an issue with one of these, I could set it higher or lower
for that individual one. Nice.
Precisely, precisely. But in this particular case, that's the lowest. In fact, it's kind of rising now. Now my lowest is 10.
That's so strange. And that's just because these, when they're manufactured, they're not super, super precise.
They're not super precise. And also, remember, an analog environment, it's always changing. Just the fact, look at this. If I do this. Alex, here, go to the table shot. All I'm doing, I'm not changing the potentiometers. I'm like wiggling the wires. And that's actually a problem with breadboarding, because in changing this, I'm slightly messing up the connection.
Oh, wow.
And it's enough to change the values.
Yeah, so your values might even change once you solder everything together.
Yeah, and which is why I'm using the map function along with my error correcting to sort of give me a margin of error.
Yeah.
And that's actually kind of important. You want to make sure that unforeseen values aren't going to throw the Arduino into a crazy state.
Right.
All right. So again, let's go back to that screen. I can set any value I want. and it will set the temperature of the light. And then over here, this knob is actually going to control how bright that color actually is. So I can find what temperature I want to be using for a particular scene, and then do that or that. Now, there is a way to do this without the brightness. What I could do is I could just say it's going to be a combination of this, and I can turn down the lights to adjust my brightness. But the issue with doing it that way is then I have to change my color temperature in order to change the brightness. I would rather it be, I have the color I want, now I can play with the brightness.
Right, right. No,
so what do you think?
That's awesome. That's really cool.
Now the cool thing about this project is we're going to be using it for an on-camera light. So I'm going to be combining a bunch of these WS2812 lights with this exact programming, with its own power source, and it will be a top-of-camera light. But you had another use for this.
I want to use this for like above my cabinets in my kitchen lighting. I want to be able to have like maybe the Arduino in a 3D printed box like on the side of the cabinet and be able to dial it in for colors that light up above the cabinets and like reflect on the ceiling. Or even if we could get like a Bluetooth shield and then connect to it with the phone, so when I walk into my house I can turn on the lights and light up the kitchen.
Yeah, exactly. And see, that's the other cool thing. We could combine this with, say, the One Shield that we just took a look at.
Right.
And suddenly you could control your lights over the internet.
Yes, that's what I want to do.
You do that? All right. Folks, I know that this was a lot of information, and in the next episode, either the next one or the following one, because I think the parts for the Stepduino might actually be in now, but we're going to show you how to turn this into an actual product. We will give you all the programming, we will give you the entire parts list, and of course we're going to give you the code. In fact, the code for this project is right now, it is available on the internet. If you're watching the pre-record, if you could guess the link, you actually could pull it down. But you're going to find that in our show notes. And where are those show notes, Brian?
You're going to want to go over to twit.tv/KH. And not only are our show notes there, but there's all the links that you'll need for downloading or subscribing to the show. Or if you missed something, going back maybe another episode or two to catch up on a project. And yeah, there's our stepper motor project with all the links and stuff. Look at how pretty it is.
Yeah, I got it working last night, but without the parts that I wanted to create and the parts that I bought, I'm like,
not worth it.
I want it finished. I want to like feel like I could give this to someone.
Wouldn't be the first time we had a jank project on the jank.
We should call the show like Jank How. No jank.
We did it for the jankiness.
Yeah, absolutely. We do it for the janks. All right. Also, don't forget that we have a group on Google+. If you go to Google+ and search for Know How, you'll find us with 10,000 plus members of our know-it-alls. It is the best place to post pictures and videos of your projects, which may make it onto the show.
Right.
It's also a really good place to help people. If you've reached that point in your knowledge experience that you believe you can help the noobs, please join. And if you are a newbie and you are at all confused, daunted by what we do here on the show, it's a great place to ask questions and really just find some people who have the same kind of maker mindset.
Well, yeah, and that's why we call them the know-it-alls, because not one person knows it all, but collectively we can fill in the gaps.
Yes, that's actually, maybe that should be the name of the show, The Gap Filler.
The Gap Filler. Yeah, that's a different show.
No. Okay. Of course, that's not the only place that you can find us on the socials. You can find us on Twitter. I'm going to be twitter.com/PadreSJ.
And I'm at cranky_hippo.
And our director,
who did a fabulous job today.
Fabulous job. I'm very impressed. So he actually gets to have his name right. Alex Gumpel. You're going to find you're going to find him on twitter.com/ANELF3. ANL3. Go find Alex. He's a good man, and you know what? Sometimes he needs hugs.
That's a lie.
He loves hugs. I gotta turn off that.
Yeah, just turn the monitor.
It's off.
Good.
It's off.
Until next time, I'm Father Robert Ballecer.
Yeah, I'm Bryan Burnett.
And now that you know how,
Go build it.